Good morning, everyone. I just realized looking the last talks that mine is not at all in bio stuff. I mean, just I will talk about wood, so there is no bio inspiration, there is no all the different definition you mentioned, but at least it's bio because it comes from wood and trees, so from the living world. So my name is Romain Lehnebach. I am from the Wood Lab in EcoFog Joint Research Unit, and today I'm going to present the work of the whole team. So not my personal work, but the work of many people involved, and also with strong support from the laboratory of the natural substances of EcoFog and partners from Montpellier, namely the research unit BioWeb and the laboratory of mechanics and civil engineering in Montpellier. So the name of the talk is the diversification and valorisation of Guianese timbers and wood projects. It's actually the main concern we have in the lab. Of course, we have other, but this question animates a lot of debates. So a few words of context. French Guiana is a territory facing multiple challenges. There is a high demographic rate. Oh, sorry, what happened? High demographic rate, making that the demand for sustainable construction materials still increases, a low employment rate, and also an issue with carbon storage. And wood and its industry can solve at least partially many of those issues by, of course, providing sustainable material, also providing jobs, and also storing carbon in construction. So let's see how relatively well diversified timber industry works. So basically we have the forest, or at least trees in plantation or whatever, but those trees are exploited to produce logs. Finally, those logs are sawn to produce sawn wood, and those sawn wood are used to make house buildings, I mean, to construct. All those, yes, and also sawn wood are used for furniture making as well. All those steps also produce what we call wood residues. And those wood residues can be used to produce engineered wood projects. Okay, basically fiberboard or glulam or plywood, many kind of wood that you have on your seat, for instance, today. And those materials also are used for building. And finally, the rest of the wood residues is generally used as fuel wood to produce energy. So this is a well-diversified timber industry. Of course, the shame can be much complicated than this one, but it's already relatively well-diversified. But in French Guiana, it's not the case, because the engineering wood products are not products actually in French Guiana, and the furniture, the cabinet making sector is not well developed. So it means that all the wood residues is used as a fuel wood to produce energy. Oh, it's very sensitive. Okay. So let's have a look at the timber production in French Guiana. So it's only based on forest exploitation, so natural forest exploitation. So here you have the evolution of the timber volume harvested per year during the last decade. And we see that in average, we produce around 75 to 80,000 cubic meter of logs. But then if we look in more detail, we see that 80% of this volume is rely on only 5 species, okay? With the angelic, so the dark blue one, 50% of the volume. So the exploited species are not diversified at all, while we have a huge biodiversity in the forest, almost 2,000 species in the forest in French Guiana. Very recently, the strategic plan for forest and wood sector fixed the objective to triple the production over the next decades. And this seems to be a huge work. So we have to find solution, and one possible scenario is to produce wood in both plantation and natural forest. So it means that we have to set up plantations, but also diversify the harvested species in natural forest, of course, because if we continue to only exploit 5 species and we have to increase the volume, it means that those species can be threatened. And finally, the idea is also to valorize as much as possible the residual resources. So here I will not talk about plantation at all. I will need a complete talk on this, but I will talk about diversification of species and valorization of the residual resources. So first, for diversification, we have to define the resource of interest. What is an interesting species to be used? So first, the resource has to be available. Here on the left, you have a plot of the top 50 of the tree species that reach the exploitable size at the Parcours station. And we see with the black arrows that represent the exploited species that most of the current exploited species are the most abundant. And finally, the resource has to be durable. What do we intend by durable? So we test the durability of the material of the wood by feeding wood-destroying organisms with the material to test. And at the end of the exposure period, we assess the durability. Basically, if the mass loss is low, we say that the wood is durable. And inversely, if the mass loss is high, the wood is not durable. Okay. Then if we cross the abundance data and also the durability data that we have in CIRAD databases, we can clearly see that most of all the exploited species produce wood that is durable. And on this plot, we can also see that more than the half of the species produce wood that is not durable. So if we want to diversify the production, it means that we will have to go much deeper into those species and try to use them. But of course, the wood needs to be durable. Let's imagine you have a house and the wood is not durable. You have termites and fungi and so on. And of course, your house will not last for a long time. So it's really important that the wood is durable. So there is several options. The first option is to use classical conventional treatment. So basically, those treatments are made from molecules that are derived from the petrochemical industry. But here we are not interested by such treatment. Here we are much more interested by valorizing the wood residue for this. I recall that the species that are currently exploited have wood that is quite durable. So the idea is to make those two components, basically the logs and the wood residue, interact. And the idea is to take what is durable in the wood residue to impregnate the non-durable wood. So what caused the wood to be durable? Wood is an assembly of vessels, of cells, sorry. Each cells are separated by what we call the cell wall, and the cell wall is made of macromolecules, namely cellulose, lignin, and hemicellulose. And there is also a fourth kind of molecule that we call extractives. They are low molecular weight molecule and impregnate the cell wall. And those extractives give to the wood its natural durability. Finally, if we look at the volume as of the harvested volume as a function of the durability or the mass loss, we can clearly see that most of the exploited species are durable, and the size of the point is also proportional to the extractive content of the wood. And here in red, we selected Wakapu, Wapa, and Grignon because they are quite durable. They are relatively a lot exploited. And also they have high extractive content. So they are a resource of interest that we want to use to proceed to biotreatment of non-durable species. So we selected one very abundant species in French Guiana that we call Yayamadu, so Viola micheli. Its wood is not durable at all, but we want to exploit it and valorize it. And we try to impregnate the wood of this species with different kind of extracts, so from the three species I just mentioned. So we have the mass loss. So basically, shorter is the bar on the plot, more durable is the wood. And we got a very interesting result using Wakapu extract with the 8% concentration solution. The mass loss or the durability of this treatment in the Yayamadu is equal to a commercial treatment. So it's a very interesting result because it means that we can replace commercial treatment with bio treatment or bio-based treatment, and also that we can transfer the functionality from a given wood to another one. So we are at the very beginning of this research field. Very recently, Emma Kieny started her PhD on this topic. She will specifically address many questions like the relationship between the phylogeny and the activity of the biological activity of tropical wood extractives, as well as attempting to develop processes that are environmental friendly for the extraction and purification of the molecule of interest, and to propose biotreatment formulation that optimize the impregnation rate and also the retention of the molecules in the wood. So extraction, the production of extractive and the biotreatment of wood is a potential lever to increase the quantity of wood that we can exploit. Now I would like to focus during a few slides on the project led by Julie Bossu from the CNRS at the Wood Lab in Ecofog. This is an ANR project that the idea of the project is to produce insulation fiberboards from wood residues. So the idea is to take sawdust, crushed woods, I mean every kind of wood residues, and then to shape insulation fiberboards using thermomechanical process. At the end, the idea is to assess the different products against the local hydrothermal conditions. So to look how the microstructure properties, thermal properties, mechanical ones are impacted by the climate in French Guiana. And this will be followed by in situ validation using technical demonstrators that are basically tiny house. So those small house will be instrumented with sensor, and the insulation fiberboards will be set up inside. And the idea is to record the moisture outside and inside, as well as the temperature. Also the hygrometry and the mechanical parameters inside the panel, inside the fiberboard, to finally try to model the thermal exchange in between and to assess the efficiency in situ of the project. And this work is a collaboration with the Technological Institute of Kourou. Finally, Julie wanted this project not to be just only a technological model, but she wanted that an holistic approach. So the project includes also an environmental model through life cycle assessment and the computation of eco-scores, but also a biomechanical model to assess the sustainability and the economic viability of the let's say the creation of a new product inside the network, inside the wood sector. So the idea is also to look at the network typology. If with this new project, does the system will remain stable, sustainable, and flexible. Finally, all the knowledge will be concentrated in a book of knowledge. So it will be an online tool that is accessible for everyone. And you, in this kind of tool, you can find many data on the material, the technology, and so it's a tool for communication. So we see that we also have the possibility to produce engineered wood projects based on wood residues. Finally, I have a last example. So sorry for the quality of the picture on my computer is definitely different, but it's relatively simple. So you have the distribution of diameter breath rate of trees in Parakou. The red line is placed at 20 centimeters. So the idea is just to show you that below 20 centimeters, 60% of the trees are present. And all those small trees, we currently doesn't valorize them, and they could be quite substantial in clearings. Also, when there is damage in the forest during exploitation, so there is also a need to exploit those trees. But this is an old story because Amérindians and Palicourt mastered definitely the building the construction using small round wood. So the idea is just to remove the bark and to use the wood as it is. Okay, so this picture was taken by Clémence Augeron a few years ago. She studied the use of round wood in the Palicourt culture with an ethnobotanical approach, and currently Maëva Leroy is doing a PhD thesis on a very similar topic, but more the link between technological properties of round wood and architecture. So I will not dive into the technological details of the PhD thesis of Maëva, but we got one very interesting result when we compare the mechanical performance of the round wood with soundwood. So in orange, you have the soundwood. So you have the stiffness, basically it's the rigidity of the stem as a function of the density. So those two variables I linearly related. So this is quite common in wood science. But what we see is that the use of when we use roundwood, actually the stiffness is much higher for a given density than the soundwood, and is really interesting because it means that we can use them directly as they are, so in a round shape. And the other question, which is more philosophical, is why do we degrade a trunk that basically was shaped by evolution and by tree growth during hundreds of years? So this is something that we want to go further. Of course, the roundwood are not so easy to use, because using a board is quite easy, and jointing two boards is relatively easy because you have two planar surface, which is not the case for roundwood. So it means that we have to innovate and to find new ideas to how to join those wood. But we have there's many potential application that run from the heavy duty structure, like the bridge you have on the left side, to much simpler structure like this emergent housing, that both structure use metallic sockets to yes, I'm done almost. So finally, in blue, you have all the perspective, the possibility that we have, and of course there are many others. I just pinpoint some of them. Final words, so I'm done. So the Guianese biodiversity offers an enormous potential for the sustainable development of the timber industry in French Guiana. But of course, it needs, and it's a call, because we have to continue to characterize natural substances, also the properties of the material, because so far we know relatively a lot about wood, but there is still many things to discover. So this is really important to continue the work of characterization. And finally, those innovation must be accompanied by the adaptation of the current practices. For instance, if we want to valorize non-durable wood, basically what is done currently is that the trees are felled and they can be let on the ground for many years. But those trees are durable. The wood is durable. But we can't do this with non-durable wood. We can let the trees on the ground, in the forest ground, for many years. So it means that we have to adapt to change the practices. It's one example by among others. And thank you very much.
Thank you, Romain. And do you have questions? Actually, I've got one.
Yes.
Yeah, you spoke about the small wood.
Yeah.
I was wondering, what is the market today in terms of volume in French Guiana?
This is something that we actually don't know at all, because those wood are not used here, I mean, in an industrial way. So we don't have any idea of this. The idea of the PhD of Maeva was to show that we can do something with this wood. And then one possible market could be lightweight structure like bus shelter or things like this. But no, we don't have a clear overview on that.
Sorry, if anyone else wants to ask questions, you don't hesitate. My question was for both of you, Romain and Jean-Paul. What does this presentation mean to achieve the status of nature-based solution? It's not totally clear to me. There's a biodiversity component. It's if the logging industry is more efficient, it will preserve more biodiversity. So that's there. There's an economic aspect. Is that the construction aspect that's missing?
I think I can reply to this. I can give an answer. I'm wondering exactly the same thing as Jerome. I mean, we have the ability to work with wood, so it's basically a biomaterial. So we have the feeling that we are into bio things, and I feel a bit confused now with the definition you gave during your talk. So I can't have a clear answer to this.
Well, I don't know if I should share those words now. Maybe we can talk together. But I have an impression it's not nature-based solutions in the way, well, so maybe we can talk together. So we need to have a challenge, a societal demand or challenge. We need to have both biodiversity and economic and societal benefit. It should be cost effective and it should be built from the bottom to the top or co-construct. So I'm not sure if I am the one that will give these answers. Maybe you can give the answer.
Yeah, I think we almost tick all the boxes, perhaps excepted the last one you mentioned. So yeah, almost done though. That's good.
Yeah, so the whole point of this talk, I think, in addition to the technology, and which is fascinating, really, and thank you for that. The point is that it grounds a little bit this concept of nature-based solution and shows how diffuse some of the implementation can be. So thank you very much.
You're welcome. Thank you.
One last question. There's a young lady here.
Thank you very much. Just have you think about propose a study about the impact to harvest only small stems in French Guiana on the community, on the forest community, for the regeneration and for the replacement of all the species in the forest.
I see what you mean. The idea of the at least the selection of the species was based on different scenarios. First, some species were selected because they are sciaphilic species, so they have very narrow stem, but they're actually relatively old, so they attempt already to reproduce. So for those species, it's the study you propose is interesting, and I think you want me to go to the sustainability, the persistence of the species in the forest if we exploit the species. So yeah, it will be very interesting to look at this. But just to finish my word, we selected some species that will never reach a big size. So those species already produce fruits and already reproduce. So we are a bit in the same case as when we harvest the big trees, like the big angelique and the big gonfolo. So for this, I think it's okay. And then the idea was also to try to find a way to valorize all the small woods that will be cut anyway, like in the case of land use changes or clearings and so on. Yes.
Thank you. I agree with Jérôme with this question about nature-based solution. And there is another concept, which is nature's contribution to people. And to me, this is way closer to nature contribution to people. But I have the same question. Do you know the both concepts and do you know the overlaps between them?
Not really.
Okay, me neither, but
I heard that
there is a real field of nature contributions to people.
I thought that nature contribution to people was a kind of new word or expression to replace ecosystem services. This is I have in mind, but I'm not sure about that. Yeah.
Okay. Thanks again.